In this video, I'd like to talk about the use of descriptive statistics. These up here are examples of descriptive statistics, and before I tell you how to make tables that look like this, I'd first like to state what a descriptive statistic is. In this context, what we're talking about is for any given variable, something which has a bunch of values associated with it, a bunch of measurements, we want to know some information about all of those measurements, kind of like metadata about the data. In this case, we have for a list of stock market returns that generally go between negative 35% and positive 35%, but there's a lot more than we can know than just that. So let's get to it and use the stat pack data analysis to understand more about the range of data that's listed here. So first I'm going to look at Microsoft, so I will go Data, Data Analysis, and I'm going to go to Descriptive Statistics, and it says what's the input range, and I'm going to go from there to there. I've already clicked that there are labels in the first row. By default, it wants to create the information on a new spreadsheet, or worksheet, but I'm going to leave it here. So I'm going to select that field. I'm going to want summary statistics. So I've selected the range. I said I want labels. I said where I want to put it on the page and what I want. So I will click OK. And there's my information about Microsoft. Now I want to do the same thing real quick with Intel just for comparison's sake. So I'll go Data, Data Analysis, Descriptive Statistics. Starting here, I will grab that column, and then instead of there, I will go right there. Leave the other things the same. Okay, I'm going to zoom in a little bit, and for Microsoft, what we know is that their average returns overall are about 3.2%. So, and this is month-to-month comparisons. So in any given month over a period of time, maybe about 10 years that's listed in the data, that in any given, from one month to the next, the average change is an increase of 3.28%. Over here for Intel, looks very similar, an average change of 3.2%. I guess if you include the 8, then this one is slightly better on average. Now, something that is comparable to the mean is the median value, and that means we just line up all the values from smallest to biggest and pick the one in the middle. And oftentimes this is a better measure than mean. And the reason for that is the mean is highly affected by outliers, large numbers in the data set. I'll give you an example of this. I know of a college that advertises its the average salary of its graduates from its law school. What they at one time did not reveal was that one of their graduates was an NFL quarterback, and so because of that, the millions of dollars that that person was making averaged in with all the others kind of distorted things. Whereas if they just took the salary that was in the middle of all their graduates listed from smallest to biggest, that would be far more appropriate. I just want to compare with some other columns that I have up here to see if there's something different. It looks like GM is far lower than what we've seen, and Cisco is better than what we've seen. So kind of interesting. In terms of mode, if something shows up more than once, then that will be listed here. Now, standard deviation and sample variance, these numbers have to do with how spread out the data is from the mean. So if most of the numbers are about 3.28, give or take a tiny bit, then the standard deviation and the sample variance numbers will be small. If on the other hand these numbers are large, then that means that there's a lot of variability about the mean. So if we were to kind of draw a histogram, we would have a really wide histogram if the standard deviation is big, and we would have a really narrow, maybe kind of steep histogram if there is not a lot of variability about the mean. I'll jump down first before I talk about kurtosis and skewness to these numbers right here for range, minimum, and maximum. These make intuitive sense. What's the minimum number in the list of data? We can also find this using the min function, so equals min in Excel and then grab the column of data, or we could do equals max and we would find the same thing. And then if we were to subtract the difference between these, take this number less this number, we get the range. So this is also a way for us to see how spread out the data is. We see that Intel Corporation is more spread out. We also see that, and there's just some other things we can look at. We can, even though their averages are about the same, we see that the minimum is lower, or is lower for Intel. So they have they've had a worse month-to-month loss than Microsoft has. And in terms of maximums, Microsoft has had a better 1 month gain. Now, one of the things I talked about, I forgot to talk about kurtosis and skewness. So the ideas of kurtosis and skewness are that kurtosis means roughly, this is generally what people say. They do a mathematical calculation, and kind of the general assumption about kurtosis is that if this calculation comes out as about 1, then it looks like, then you know that the histogram of this data is going to look kind of like a normal bell curve. But if the number is higher than this, then it's going to have a high peak, and if it's lower than this, then it's going to this number, then it's going to be kind of flat, like a plateau. So it's going to go up and go across and then come down again, and it could be relatively wide compared to a nice smooth curve. Skewness is representative of whether there's a tail on the data. So typically, so a positive skew means that there's a tail going off to the right, and a negative number in the skew indicates that there's a tail going off to the left. Now, with the kurtosis and the skewness, the rules I just tell you may not always apply, but that's generally what people assume. Okay, so we've talked about averages and the variation about the mean, and we've talked about the shape of the curve, whether it's got a smooth top or whether it's got a tail on the left or the right, and what the min and the maximum are. So based on that, we can actually know ahead of time what a histogram of that data might look like. So here we have a graph of Cisco, a histogram of that. If I go back up, we see the mean's about 0.05 and a standard deviation of 0.122. So between 0 and 1, that's kind of the average of the data, and although to my eyes, just eyeballing it, doesn't seem like that would be the case, that the average of all the numbers falls there. So there's something a little funny about that to me. But the way it's supposed to work, though, is that you should be able to visually see things. One thing you do see things that matches up with the number is that kurtosis number about 1. It does look like a nice bell curve. In terms of the skewness, let's go again, look at Cisco. That's a relatively low number for skewness. It's positive, so that implies that there's a slight right tail to this. It's not really noticeable. I'll mention something about the standard deviations. Standard deviations tell us that, well, they do a calculation to create the standard deviation, and if we go out one standard deviation, so 0.12 from the mean for Cisco, if I go out 0.12 from there, that actually, if I go plus and minus in both directions, that picks up 68% of the observations. If I go out 2 standard deviations in each direction, so take the initial mean and add on that number for standard deviations, put that on there twice and go in each direction, that'll pick up 95% of the observations. And then if I do 3 standard deviations, that'll get me about 99% of the observations. And why is that important? Well, it helps you identify if there are any outliers. So let's actually talk about the issue of outliers. How would we, I've said that it's very bad, and then so for that reason median might be better, because means can sometimes be misled by outliers, but you can actually fix the problem of outliers by doing something in Excel called trimming the mean, which means we're going to take off a certain percentage of the highest and the lowest observations. So for Microsoft, we see their standard number is 0.03, 3.28% up there. But if I type in equals trim mean, and I pick, first off I will grab the Microsoft column. And the next thing it asks me for is the percent. So how much do I want to cut off? Well, I'm going to cut off the top 2.5% and the bottom 2.5%. So that's a total of 5%. So the number that you put in there represents a number that cut in half you want cut off from the top and the bottom. So I type that in and I get 0.033. So because the number went up from the mean, if anything, that means my outliers perhaps were on the low end. Alright, so what I've done then is perhaps gotten a little bit more accurate mean. Another thing that we can do is, based on this idea of standard deviations, we can determine a range that's 2 standard deviations up from the mean and 2 standard deviations down from the mean. So if I go mean plus 2 standard deviations, this is just for I'll go minus 2 standard deviations, and then I'll go mean plus 2 standard deviations. The way that I can calculate this is I can go equals, take that number, minus 2 times this number, and now I've got well, this must be a really big number, so let's format this. Okay, so if I go mean minus 2 standard deviations, and if I go equals this number plus 2 times the standard deviation, now I have a range which contains about 95% of the observations, which helps me again understand where the bulk of my data is found, and if any numbers that I'm looking at, if I'm picking out particular numbers, I can say, hey, that seems like it falls outside of the normal range. Maybe that's a cause for concern in including it in my analysis.